Alright, welcome back. We have Unit 4, Lesson number 4. We're going to start with number 5. Number 5 asks, tell whether the angle-side-angle postulate can be used to prove the triangle is congruent. If not, write not possible. So the question is, can we use angle-side-angle to prove that these triangles are congruent? Well, looking at the triangles, I see that I have an angle there, an angle there, and then using the reflexive property, I see the length there is the same for both triangles, so I have a side. I have angle, side, angle. So I can say yes, they are congruent based on angle, side, angle. Alright, number 6 is asking the same question. Can we use angle, side, angle to prove these two triangles congruent? Well, these parallel lines here and here are a clue. This is my transversal here, so I know that this angle down here is equivalent to the angle up top. I'm going to clear that out, clean it up. This angle is equivalent to the angle up top. We also know based on the reflexive property that this line is equal to that line. So we have an angle and a side. So we have an angle and a side. We do not have enough information, so it is not possible. The answer is not possible. Number 7, same question again. Can we use angle, side, angle to prove these two triangles congruent? Well, just looking at the shapes, I see that I have an angle, and then I have a side based on their numbers. So it appears like we can't prove it because I just have an angle and side. But looking more carefully, we should note that these two angles are congruent because they're vertical angles. So because those two are congruent, that gives me another angle. So I get angle, side, angle. Angle, side, angle. So yes, these can be proven congruent also. Okay, for number 8, what we're trying to do is we're trying to prove that LMK is congruent to JMK. So these two triangles are congruent to each other. We have some given information that's in the drawing. The A says KM is congruent. So right here, KM is congruent to KM. And the reason we would know that that is congruent right there is because of the reflexive property. So now that we know that segment is congruent, we have an angle, a side in the middle, and an angle. So we would say they are congruent based on angle, side, angle. Alright, for number 9, we're being asked, can we use angle, angle, side, or angle, side, angle to prove these two triangles are congruent? Looking at the triangles right away, what I see is I have a side and an angle. And there's one more thing you should be seeing in the picture though, and that would be your vertical angles again. You gotta see those vertical angles. So that gives me a third angle, and now we have side, angle, angle. Just like over here we have side, angle, angle. So angle, angle, side would work. Alright, number 10 is asking the same question again. Can we use angle, angle, side, or angle, side, angle to prove these two triangles are congruent? Well, starting off, I got to start looking for things that might be congruent. They don't give us anything in this picture, but they give us a clue with our two parallel lines here. And here's my transversal right there. So using that information, I should know alternate interior angles are congruent. So this angle right here is congruent to this angle up here. Also, that transversal going through the middle is a side of each triangle, so it's congruent to each other. So the reflexive property says that's congruent. So now, looking at this, I have a side, oops, sorry, keep doing that. I have an angle, and a side. I do not know that any other angles in this picture are congruent. I don't know for sure that this line is parallel to this line, so I can't know if any other angles are congruent. So number 10, the answer is not possible. Not possible. Oops. Actually, I didn't realize in the drawing this side is parallel to this side. Therefore, knowing that it's parallel, that means I can say that this angle 1, 2 here is congruent to this angle due to alternate interior angles. So we put an A there or an A here, and I have angle, side, angle, so I could use angle, side, angle to prove they are congruent. Alright, number 11. Angle, angle, side, or angle, side, angle. Can we use either one of those two to prove these two triangles are congruent? Initially, this looks like a pretty easy problem. I have the reflexive property telling me that this segment's the same as that segment, therefore these lines are congruent. So I have over here angle, side, angle, all done. Here's the problem. I look up to the other triangle and I have three sides, but I have angle, angle, side. So on one triangle I have angle, side, angle. In other words, the side is between the two angles. And on the other triangle I have angle, angle, side. The side is not between the two angles. Because these don't match, this does not work. It is not possible. They are not congruent. Alright, what number 14 is asking is what additional information do we need to prove that these triangles are congruent using angle, angle, side. Angle, angle, side. Looking at the triangle, it's like, wow, it looks like there's nothing on there, but there actually is. The reflexive property tells me that line is equal to itself. This line right here is a transversal because this is parallel to this. So, because of that, we know that this angle is equal to that angle. So now we have a side, and we have an angle. But we want to make it angle, angle, side. So then we're going to have to go to the next available angle, which is angle B. If we go down to the bottom, that would be angle D. So what we need to know, what additional information we need, is that angle D is congruent to angle B. I should put two lines on both of those. D and B are congruent. Now we have angle, angle, side. Angle, angle, side. But what the question asks is to write a congruent statement. So right here I wrote triangle MOP, M-O-P, is congruent to, and when I do this, oh my gosh. Oops, my mistake. Angle D is congruent to angle B. That's it. Nothing more. Videos are hard to edit, so we're going to have to leave that little clip in with the boo-boo. On to the next problem, though. Alright, what number 19 says is write a congruency statement and tell the postulate that makes those two triangles congruent. While looking at the triangles, we have an angle and we have an angle. And the reflexive property in the middle again tells us MO is congruent to MO, so we have a side. So we know that it's angle, side, angle, but now we have to write a congruency statement. So that's our postulate. Here's our congruency statement. Triangle MOP is congruent to, now because I use the M here, in the first spot here. My first letter I have to write on this side is going to have to also be M. My O came second down here, so I need to write O second over here. The one in the corner here, the P, came third, so then I have to write the N last. MOP is congruent to MON. Just remember, order absolutely matters. Alright, last one. We have to write a congruency statement and state which postulate proves the triangles are congruent. So the first thing I'm going to notice is that I have an angle here and an angle here. And that's all the information I start with. But I have a parallel line, and it's cut by a transversal. Cut by this transversal. If I see that, I would know alternate interior angles are congruent. So clean that up real quick. And alternate interior angles are congruent. I also know based on the reflexive property that TS is congruent to TS. So this line is congruent. So now I have angle, angle, side. So angle, angle, side is the postulate. And now I have to write the congruency statement. And remember, order matters. So triangle UST is congruent to, if we look at our picture, the U goes with the R. So R, the T goes with the A, because these two angles are congruent. And the S goes with the S. And order matters, all done. Hopefully you enjoyed the video. See you next time.